Welcome to the second in our IPF tech podcast series. Today we're going to be looking at the IPF connector framework, particularly accelerating integration with IPF connectors. Today, glad to be joined by Pat Altai, who's one of our principal engineers. Really good to have you here, Pat.
Thanks, Matt. It's good to be here. Looking forward to the discussion today.
So I think as anybody who's worked on payments implementations will know, integration can be as much as 80% of an implementation. So having a framework that standardizes and accelerates integrations is absolutely fundamental. Pat, do you mind giving us a bit of background about the IPF connector framework and tell us a little bit about the design goals?
Yeah, sure. As you mentioned, when we've been to various financial institutions to implement IPF, we saw essentially a gap where and as you mentioned, integration is the majority of what we find to be the most of the work, and indeed most of the defects, and the whole shebang essentially. So essentially, the main reason that we did some analysis, and the main reason that we found for the issues and for the reason why it takes so long is essentially that there's a large amount of deviation in all the various types of integration that we've seen. So the main aim of the connector framework is to essentially create an abstraction layer between the internal IPF application, or the IPF flow, and the sort of the different integration methods, and the different protocols, and the different contracts and interfaces between all the different bank systems that we may have to integrate with. So the main design goals for that, in order to achieve these goals, essentially was the top one for us was modularity. The main reason we saw for bank integrations sort of looking really heterogeneous, looking different for as many implementations or integrations that there were, was that some integrations needed this, but some didn't need that. Some integrations needed, for example, correlation, but this one didn't. This one needs crypto, this one doesn't. This one needs validation, this one doesn't. And there's a sort of a Venn diagram of all the various things that various services do or don't need. And so the top thing for us was, the top design goal for us was that the connector framework has to be modular. That is to say, you only plug in what you want, and you don't plug in what you don't want. And that way, you don't have to have lots of different integrations that, I can't use connectors because of X, I can't use connectors because of Y. Everybody should be able to use a connector, and if you don't want to use a specific part, then don't use it. And if you want to use a specific part, but whatever's out of the box doesn't let you do it, then you can roll your own. You can effectively write your own correlation, write your own mapper, write your own validator, and what have you. So that's the main point in modularity, and the sort of modular components that we've got are correlation, which I've mentioned. So essentially, we'll touch on that a little bit later, but essentially it's for correlating requests and replies, of course. Logging, self-explanatory. Crypto, by default, we support symmetric, but again, because it's pluggable, you can of course plug in whatever implementation you have, whether it's an HSM, hardware security module, or any other crypto implementation for that matter. Validation, by default, we support XML validation, JSON schema, and Bean validation as well for the Java programming language. But it's also possible to implement your own validation, whether it's business validation, for example, mutually exclusive fields, or what have you. Mapping and self-explanatory. Again, a big, as you know, a big part of integration projects that we see. Mapping is a big topic, and we have the IPF, the ICON mapping framework, which lets you convert from between different types, different canonical domains. And of course, metrics. People always want to know what their service is doing, what IPF is doing, how fast is it going. So we have metrics, both on a sort of macro level, which is how's the app health overall, and on a micro level, where we have, for example, open tracing, which lets you trace a span of a single transaction throughout the whole system. And indeed, it's possible to connect these spans across different components, not just IPF. So those are the sort of modules that are available, and one of the main design goals is modularity, of course. The connector framework is also reactive. So internally we use Akka Streams, or Alpaca, which is an Akka Streams implementation strictly for integration. So essentially, we have implementations for JMS, MQ, Kafka, HTTP files, and the connector, because it's modular, essentially you can plug in your own implementation for whatever the transport is. So for example, if you'd like to connect to a database as a connector, that's possible. If you'd like to connect to an S3 bucket, that's possible as well. So just because we haven't written it doesn't mean that you can't do it yourself. And indeed, if we find it interesting enough and if it might be useful enough, we actually can just take it in-house and look after it as well and provide support for it. So and the point of reactivity is that we signal demand upstream. So instead of sort of being flooded by work, we just say, I'm not ready for more work at the moment because I'm totally saturated, but I'll let you know when I'm ready for more work. And so that really helps. That helps you not be overwhelmed by work when the amount of work that's coming in is greater than what the system can handle, which is very likely for situations, as you're probably familiar, like end of month and so on, when loads can be very irregular. Finally, it has a Fluent API that's easy to use, so it's well documented, and it uses modern API design practices so that it's really easy to get started and get going. The main goal is to effectively reduce the barrier to entry, so that there's no reason why you wouldn't want to use connectors, and we spend quite a lot of time making sure the developer experience is really smooth. So those are the main sort of design goals that we have for connectors, and we're constantly revisiting them to make sure that we're always meeting them.
Thanks for that, Pat. And I think what you touched on there, empowering, our clients to be able to use these things and to not be dependent on Icon is a wider fundamental goal of Icons. So there are different types of connectors, aren't there? Do you mind telling us a little bit about the different types of connectors and how they differ from one another?
Yeah, sure. So we actually have three connectors for three types of connectors that can be used. So initially we have the send connector. Send connector is just that, so it effectively just sends messages to any endpoint or over any medium. So the idea behind the different modules is that they're not tied to the transport. We have the concept of a connector and a connected transport. The connector itself contains all the various modules that we discussed earlier, so correlation, logging, crypto, what have you. And then we have the connected transport, so that it's possible to do all those to implement all those different modules regardless of what the actual final transport is. So the send connector, of course, sends a message, be it Kafka, HTTP, file, JMS, we talked about that earlier. Receive connector is, again, the reverse, so self-explanatory. So receive connector receives messages over JMS, Kafka, file, HTTP, and so on. And it can also do things like receive events. So if you have any sort of push notification, we can also receive events like that over a WebSocket, say. So that's possible as well. And quite a common use case for an integration use case that we see is actually using both a pair of send and receive connectors for a design pattern, fairly well known design pattern called async request reply. So that's where effectively you send a message with some sort of correlation ID, and then whatever the downstream system is sends a response back using that exact same correlation ID to effectively tell you which request this specific response is for. We use the correlation module for that, so you can effectively say, I'd like to use this specific ID, and then we have a persistent engine that lets you correlate requests and responses, which can also span multiple nodes as well, which is very important. Because, of course, the app can be deployed over multiple nodes, over multiple AZs, and so on. So, and of course, it's possible to sometimes send a message to the same system multiple times for the same flow. So it's not straightforward, not always easy to just say, oh, I'll just use the transaction ID, for example, because actually I may be calling the same system multiple times. And so if I just use the same transaction ID every time, I'm not going to know which response this request is for because I made 3 calls. So is this response for request 1, 2, or 3? So I won't be able to tell. So that's why we have the correlation aspect and why these two are used in concert with one another. And finally, we have the request reply connector. So this is to represent, and it's really just a specialization of send connector, where we effectively, instead of just the send connector, when you send a message, it returns a future which completes with the outcome. We have the request reply connector returns again a future, but instead of the future completing with just the result of the send, did it work or did it not work, it actually completes with whatever the response was. So this is used for things like HTTP requests. So if you want to make an HTTP request, of course, it's not message based, so it has to something has to be waiting, but we return a future so that we're constantly asynchronous, and that's satisfying that reactive contract that we discussed. So that's what the request reply connector does, and it handles, at the moment, mostly sort of, I'd say 99% of use cases for HTTP, but it can be used for other things, such as, for example, requesting things from an S3 bucket, and I'm sure people will come up with lots of weird and wonderful things to use it for.
So yeah, thanks for that, Pat. So yeah, a lot of our clients come to us and say, well, we already use Spring integration, we already use Camel. What difference does the IPF connector framework make? Do you mind just talking a little bit about how the connector framework differs from those solutions already available in the market?
Yeah, I mean, the thing is, as you mentioned, quite frequently when we're doing presentations, or when we're talking to customers about integration in general, they say, well, I already have this thing that works, or how does this compare with, as you mentioned, for example, Spring integration or Camel? And the answer is that it's at a slightly higher level. As I mentioned at the beginning, it's a layer of abstraction over just the bare integration, which is what Spring integration and Camel do. Those Spring integration and Camel are great at doing that protocol level sending and receiving of messages, and indeed they have their own level of abstraction, which is a generic message type, a generic exchange type, which we also have in connector framework. But that really is just the connector transport part. But in order to create the other modules that we talked about at the beginning with connectors such as correlation, logging, crypto, and what have you, you would effectively have to do that again with Spring integration or Camel. There's nothing stopping you from doing that, but you'd have to roll your own essentially from scratch. Something may already exist in the organization, such as part of a future state architecture or engineering best practices, and that's great. If that's possible and that's available to use, then by all means use that, because as you know, one of our main goals of IPF is to accelerate implementation. And so wherever you've got something that's usable, then by all means. And indeed, the join point between connectors and IPF flows is really just a future that needs to be completed at any point. So there's no dependency on connectors if you already have something that's ready to use. So in a nutshell, the connector framework already exists to help you implement all these different modules so that you don't have to do it yourself. But if something is already available, then you can use it by all means.
Awesome. Thanks a lot for that, Pat. I think that was really useful, a really good overview of the connector framework. Thanks everybody for watching this episode in the IPF Payments podcast series, and stay tuned for the next episode. Thanks everybody.
Thank you.